Hello everybody, and thank you for joining me. We're on question 15 from our Fermat paper. And let's take a look, see what we've got here. There are 6 identical red balls and 3 identical green balls in a pail. 4 of these balls are selected at random, and then these 4 balls are arranged in a line in some order. How many different looking arrangements are possible? So the order of the balls particularly matters, but we can't tell 2 of the green ones apart. Okay, or 2 of the red ones, because we're told they're identical. Okay, so what can we do? Well, we're picking 4 of these out at a time. What possibilities could we have? Now, if for example, we picked out 4 red balls, how can you arrange 4 red balls in a line? Well, red, 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 red. There's no order. You can't tell them apart. But if I had 3 red balls and I picked out 1 green ball, suddenly there's some order that you can do. You can put the green ball at the end, or you can put the green ball somewhere towards the middle, or it could be at the very start here. So those are 4 different possibilities, as opposed to only 1 possibility if you have all the balls of the same color. And in fact, you get the same thing if you picked out 3 green and 1 red. You get sort of the same thing, just with the colors reversed. Right, so you don't actually have to list them out. You can say there's 4 here, there's 4 here, there's 1 here. Now, you have to ask yourself, can I reverse or swap the colors for that first one? Could we pick out 4 green? Well, you get only 1 possibility, 1 green, 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 but if we read the question carefully, we got 6 reds. It's possible to get all reds. There's only 3 green balls. You will not ever get 4 green. Okay. What else could we have? Well, we could have 2 of each. That's the only other possibility. And how many different ways are there to do that? And if you're going to list these sorts of things out, there are other ways to do the question, by the way. You could use some combinatorics if you know that. But if you're going to list things out, what I would strongly suggest is you have sort of a pattern, a way of writing things out. I put all the reds at the start, and then I've slowly been shifting this red through to the end. Now I'm going to move this red over by 1 and bring this red back as far as it can go. And then I'm going to move the second red over as far as it'll go, and then when I run into problems there, I'll move the next red over by 1, and so on. And you can actually list out 6 different possibilities there. Okay? So 1 for all of them being red, 4 for the cases if you have reds and greens but not equal amounts, and then 6 for another, and that gives us a total of 15. 15 different ways to do it. Now there's another way to do the question. Okay? If you realize the only thing that can't happen is all 4 greens, there's one way that can't happen, you might say, okay, if I had as many balls as I needed to, and I was just picking things out, how many different colored balls could I put in the first position? Well, there's 2 possibilities. Either it's a red or a green. The next ball could be either a red or a green. Red or a green, a red or a green. And there's 2 choices for each position. They have nothing to do with each other. So if we multiply them through, there's 16 different ways to write RG, RG in some order. To write a sequence of 4 letters with R's and G's being the only letters you're allowed. So there's 16 possibilities, but we're never going to be able to pick all of them as greens. So you do 16 minus 1 and get 15 that way as well. That's a little fancier, a little more combinatorial, but either way we can get 15. I think probably the more natural thing is just to list out the possibilities in an intelligent way. Okay? But we get ourselves an answer A, and so we get 15 for question 15, very nice. I like when that happens. And up next, we're going to be starting the second half of Part B with question number 16.